Today we are doing a question from optics. This is actually a kind of a challenging question, but try to do your best. It won't be that hard, but you have to know a couple of theories if you want to get the answer. Right. Let's read the question now. I think question will appear soon. A point source of light is placed at the bottom of a vessel containing a liquid of refractive index 5/3. A person is viewing the source from above the surface. There is an opaque disc of radius 2 cm floating on the surface. The center of the disc lies vertically above the source. The liquid from the vessel is gradually drained out through a tap. The maximum height of the liquid for which the source cannot be seen at all from above is right. Alright, now the point source is right here. Our condition is the source cannot be seen at all from above is right. If we assume I is here, right, the light can be seen if only a ray goes along the surface and it comes to our eye, something like this, right. So this opaque disc, it will cover certain level, up to a certain level it will cover the rays that is coming out of the surface. Alright, so they are asking the water will go out from the vessel, so the height will go down. At a certain point the opaque disc will be able to cover the entire rays that is going out of the water, right. So they are asking us to find this height, right. Now if we place our eye here, let's see, right, the ray will come out of the surface from refraction, so the ray will bend out of the normal, right. So now you know at a certain point it will go along the surface, that we call critical angle situation. After critical angle, if any ray comes on the surface and it will comes back, we call it total internal reflection. So from here it won't be a problem because these rays will not go out of the surface. So yes, that ray will not help to see this point source, right. Only we have to make sure the rays that is coming out has to be covered by the opaque disc, right. Let's take the disc now down, right, up to here, right. So our condition is up to here. After this last point the rays that has to go back, total internal reflection. So the minimum point here is critical angle situation. So let's assume here this is C is critical angle, this has to be C, and the length that can be covered is 2 cm by the disc, radius 2 cm. So this length is 2 cm, this is 2 cm, and we are going to find this height, right. If you can find the C value, yes, there's a chance we can find this height, right. Let's apply our equation now, right. N2 over N1 equals sine C, critical angle equation. So second medium is always 1. So first medium is N, so 1 over N equals sine C. Here in the question, yes, we are given the refractive index is 5/3, right. Let's apply the values now. 5/3, 1 over 5/3, 5/3 equals sine C. So now we are getting sine C equals 3 over 5, right. Sine C is 3 over 5, right. Sine C is 3 over 5. So let's assume this is C. Sine C is 3 over 5, right. Here to find the height actually we need tan C. Can you see that? Yes, this side, opposite height divided by height, right. So we need to find the tan value. If this is finding the tan value, now what we can do is we need to find this length. Tan is 3 divided by this length, right? So we can apply Pythagoras theorem. 5 squared minus 3 squared, 25 minus 9 is 16, root 16 is 4, right? Now we have tan C, that is 3 over 4, right? We have tan C now. So tan C here, it is 2 centimeter divided by this height h. Let's write it. So it's 2 divided by h equals tan C. The tan C value is 3 by 4. Let's subject value x, h equals 4 goes up, 8 divided by 3. Let's check the answers now. Right, here you can see the second answer is, yes, 8 divided by 3. Right. If you could do this question, that's great. That means you know theories. If you couldn't do this question, again you have to work on with your theories, because this is a bit of a challenging question. So you have to gather your theories to do a challenging question. You have to practice challenging questions, because in a paper you will be getting at least 10 to 15 challenging questions that are new. So if you have done challenging questions, the NIP questions will look at least a bit familiar. So that's the secret behind doing challenging questions and doing lots of questions, because in the question paper, the questions will appear a bit of a similarity. You will see, okay, I have seen this question. At least you will understand, okay, I have seen a bit of a similar type of question. I have done some question actually quite a bit similar to this, or something like that. So something will come into your head. That's how you are doing difficult questions. So that's the secret behind it. So try lots of questions. Good luck.